Hi there, I am your explainer, and today in this video, I am going to explain about Taipei 101 steel earthquake resistant ball. Taiwan's tallest building height is 508 meter, designed by the local architectural firm C.Y. Lee and Partners. The skyscraper is 101 floors tall, including the spire, and has a total height of 1667 feet. I am going to tell you about main features and role of this huge ball during mega earthquakes. Taiwan is located on the Circum-Pacific seismic zone. Earthquake occurrence is quite frequent. Based on data from the Central Weather Administration's earthquake monitoring program between 1900 and 1990, Taiwan experienced over 2,200 earthquakes on average. This tall mega-structure has some unique features. You can get the sense that you are living in a kaleidoscope by using a unique floor-reflecting mechanism to provide the appearance of an unlimited horizon. There are two high-speed elevators on the Taipei 101 observation deck, with a maximum elevation of 10 meters per minute. The trip from the 5th to the 89th level observation deck takes about 37 seconds. The world's only intelligent high-speed elevators, with dampers, high-temperature ceramic brake systems, and constant pressure devices, are these ones. A great place to take pictures because it blends romantic surroundings with a view of the city skyscrapers, making for an amazing image. With rainbow lights adding to the already stunning nighttime view from this elevated viewpoint. This is undoubtedly a well-liked photo location that shouldn't be missed. Main feature of this building is wind damping ball. The wind damping ball is known by its technical term, tuned mass damper. A passive system designed specifically for a building is called a TMD. Its primary goal is to lessen wind sway, which will make working in such a large tower more pleasant. While traditional disguised dampening devices are unseen, the Taipei 101 TMD is aesthetically pleasing in addition to being practical. Viewers of the observation deck may see how the damping system functions as a whole. The damper has a diameter of about 5.5 meters and is made up of 41 layers of 12.5 centimeter solid steel plating that are welded together to form a gold sphere mass that weighs 660 metric tons. 92 steel cables, each measuring 42 meters in length and with a diameter of 8.9 centimeters, are used to suspend the damper ball. Each steel cable includes more than 2,000 independent steel wires for flexibility and a longer service life. This design has a safety factor of 4, so even 25% of the steel cable we use is sufficient to carry the entire weight of the damping ball. The greatest swing of the design is 150 centimeters. Under the ball are 8 sizable hydraulic viscous wind dampers, primary hydraulic viscous dampers. To further increase stability, the hydraulic dampers absorb sway. The 8 hydraulic dampers on the ball are connected horizontally by a bumper ring, which restricts the ball's mass's swing and keeps it from swinging more than 150 centimeters during uncommon typhoons or strong earthquakes. Taiwan's tallest skyscraper with only minor damage survived a recent 7.4 magnitude earthquake. This is partially because to its creative design, which incorporates a massive pendulum. According to the news outlet, the sphere sways in response to the movement of the building during an earthquake or severe winds, lessening its sway by as much as 40%. The 41 steel layers that make up the pendulum are suspended between the 87th and 92nd levels. It swings within a restriction of 59 inches to prevent excessive movement, and its diameter is almost 18 feet. Taipei 101 spherical damper oscillates back and forth in response to typhoons and earthquakes, which frequently occur on the island. This motion absorbs the energy from any vigorous swinging. The damper's engineers assert that it can lower interior occupant discomfort by as much as 40% by reducing the movement of the building. The CN Tower in Toronto, the Crystal Tower in Osaka, the Centrepoint Tower in Sydney, and the Citicorp Center in New York are just a few of the numerous skyscrapers throughout the world that have wind dampers installed. Many high-tech factories in Kaohsiung have one, as does the E5 Sky Tower. Consideration must also be given to wind speed and oscillation in addition to height. When Typhoon Sulik hit Taiwan in July 2013, the local wind speed measured on the Beaufort scale reached force 14. The Taipei 101 wind damper oscillated 70 centimeters in both directions at 4:10 in the morning, the most since the structure was finished. An earthquake with a magnitude of 6.1 occurred in Hualien's Shulin Township on April 18, 2019. An earthquake at 1:01 p.m. generated a record-breaking oscillation of 20 centimeters in both directions in Taipei 101's wind damper. The latest 7.4 magnitude tremor shook the island, in which sphere moves back and forth during earthquake by absorbing the force of violent swing. The pagoda-shaped building barely moved during the earthquake, as shown in closed-circuit TV footage of Taipei's skyline. In the meantime, there is noticeable shaking captured by a security camera mounted on a different building. Researchers all around the world are giving their best to save the humankind by developing phenomenal structures. Keep watching my YouTube channel for more informative videos. Please like, share and subscribe my channel, and check out my video how Burj Khalifa laser show is performed with 1.2 million LED lights.